Matrix algebra. So a matrix has m rows, so m will be going this way, and it'll have n columns, n going that way. So AMN will be the mth row and nth column. We can also have A as a composition of vectors. Matrices can only be added if they are the same size. Meaning you can add these two together, or those two together, but you cannot add those two together or those two together. Not allowed. So 2 by 2 plus another 2 by 2, for instance. A matrix can be multiplied by a number I guess that's a 3. So that'd be 2, 6, 6, 8. So it can be multiplied by a scalar. Multiplication, though. Multiplication gets a little spicy. They don't need to be the same size. They just have to have the same like inner. So let's say A is A times A is M times N, M cross N. Let's say B is P times R. And the order of multiplication definitely matters now. It is not commutative. So if we do AB, we're going to be doing M times N times P times R. And this is only defined when N is equal to P. And this will give us a new matrix with elements of M times R, which means if M is equal to 3 and R is equal to 4, then we have a 3 by 4 matrix. Or, you know, if it's and we could easily do BA too, and this would be P times R times M times N. Now R has to equal M, and then we'll get a new matrix P times N. Let's say P is equal to 2 and N is equal to 6. So that'll give us a 2 by 6 matrix. But usually you'll see like 2, 3, maybe 4 max. For example, if we have a 3 by 5 and a 5 by 2 and we want to multiply them, we can't do we can't do 5 by 2 by 3 by 5. We have to do 3 by 5 by 3 by 2 by 5 by 2, and that gives us a 3 by 2. if now we have a 3 by 5 and a 5 by 3, now we get a square matrix, 3 by 3. Let's say we want to find AB. We have a 2 by 2 matrix, and we have a 2 by 1. And these match, so we're left with a 2 by 1. So we'll be left with another vector. So we're basically just transforming the vector, like a is it a linear transformation? Yeah, that's a linear transformation. So basically we would do the dot product. So you would get this row times this column, and that's going to be for element A, and then this row times this column, the same column, and that'll be element B. So that gives us 1 times 5 plus 2 times 6, and then 3 times 5 plus 4 times 6. Remember, this is all one element. So that gives us 5 plus 12, and that's 17. And then 15 plus 24 is 39. And that's our product, AB. If we were to multiply these two together, AB, we could also do BA, but I am just going to do AB, both of which are going to give a 3 by 3 matrix because these are both 3 by 3. So the first thing to do is you're going to get a lot of sums. So multiply this by this to get this. So 1 times 9 plus 2 times 6 plus 3 times 3. Let me undo those actually. For the next element right here, it's this row times this column. So 4 times 9 plus 5 times 6 plus 6 times 3, and then bottom row, first column, 7 times 9 plus 8 times 6 plus 3 times 9. And that's just the first row. Now we're going to be using the next column. Oh, maybe I should use blue right here. This column, and now we're going to be multiplying by the next column. Well, wait, actually, sorry. These rows by now this column. So 1 times 8 plus 2 times 5 plus 3 times 2. And then 4 times 8 plus 5 times 5 plus 6 times 2. And then 7 times 8 plus 8 times 5 plus 9 times 2. And now for the final one, the final column, we have these rows multiplying by this column to give these entries. So That gives us 1 times 7 plus 2 times 4 plus 3 times 1, 4 times 7 plus 5 times 4 plus 6 times 1, 7 times 7 plus 8 times 4 plus 9 times 1. Tedious. When we add them all up together, we get 30, 84, 138, 24, 69, 114, 18, 54, and 90. So for multiplication, there are certain properties I don't really know the name of, but if we have A, B, C, say these are all matrices, then we could say A, B, C. The order, I guess, doesn't really all that matter. If we have A, then we can have AB plus AC. That one's pretty obvious. If we have B plus C times A, gives us BA plus CA. Looks like the same thing as that. If we have IA, it just gives us A. I is the identity matrix, and this is written as 1, 0, 0, 1 for 2 by 2, or 0, 0, 1 now for a 3 by 3, or that for a 4 by 4. Basically, the diagonal entries of this are equal to 1. Everything else, 0. It's a, I guess, a diagonal matrix, but that's the basics of matrix algebra.